In this session, we are going to solve NEET previous year's questions of 11th chapter 4 physics, motion in a plane. Question 1. A particle moves along a circle of radius 20 by pi meter with constant tangential acceleration. If the velocity of the particle is 80 meter per second at the end of the second revolution after motion has begun, the tangential acceleration is. So according to the problem, the radius is 20 by pi meter, velocity is 80 meter per second, and the revolutions are 2, which can be converted into radian by multiplication of 2 pi. We get 4 pi radian as the revolutions. We also know that omega square is equal to omega naught square plus 2 alpha into theta, which is similar to v square is equal to u square plus 2 as. But omega naught, the initial velocity is 0, so therefore omega square is equal to 2 alpha theta. If we substitute alpha is equal to a by r and omega is equal to v by r, then we get v by r whole square is equal to 2 into a by r theta. From this we can calculate a is equal to r by 2 theta into v by r whole square. By substituting the values of v and r in this equation, we get acceleration as 40 meter per second. Option A. Question 2. The vector sum of two forces is perpendicular to their vector differences. In that case, the forces, option A, are equal to each other, option B, are equal to each other in magnitude, option C, are not equal to each other in magnitude, option D, cannot be predicted. If F1 and F2 are the two forces, then their sum F1 plus F2 is perpendicular to F1 minus F2 according to the given problem. We know that the dot product for two perpendicular vectors is 0, so therefore F1 plus F2 dot F1 minus F2 is equal to 0. If we solve this, we get F1 is equal to F2, so therefore the two forces are equal in magnitude. Option B. Question 3. If A cross B is equal to root 3 A dot B, then the value of A plus B is. A cross B is equal to root 3 A dot B. We know that A cross B is equal to AB sin theta and A dot B is equal to AB cos theta. So by substituting this, if we solve, we get sin theta by cos theta is equal to root 3, which means tan theta is equal to root 3. So therefore theta is equal to 60 degree. And also, we can find the magnitude of the sum of these vectors. A plus B is equal to root of A square plus B square plus 2AB cos theta. Since theta is 60 degree, cos 60 degree is 1 by 2, so therefore 2 will be cancelled. So therefore the answer is A square plus B square plus A dot B whole power 1 by 2. It is option A. Question 4. If a vector 2i plus 3j plus 8k is perpendicular to the vector 4j minus 4i plus alpha k, then the value of alpha is. So these are the two given vectors A and B. If 2a is perpendicular to b as given in the problem, the dot product is 0. So if we multiply 2i plus 3j plus 8k with minus 4i plus 4j plus alpha k is equal to 0. So I component will be cancelled, j will become unit vector, then k also will be 1. So therefore 4 into 2 is minus 4 into 2 is minus 8 plus 3 into 4 is 12 plus 8 into alpha is 8, alpha is equal to 0. So therefore we get alpha is equal to minus 1 by 2. That is option B. Question 5. If the angle between the vectors A and B is theta, the value of product B cross A dot A is equal to. We should find B cross A into A. If B cross A is equal to any vector C, the direction of C vector is given by Maxwell's right hand thumb rule, and also C vector is perpendicular to each of A vector and B vector. Now if C vector is perpendicular to A vector, then C dot A is equal to 0, because dot product of perpendicular vectors is 0. And we also know that C vector is B cross A, so therefore B cross A into A is equal to 0. So therefore it is 0. Option D. 6th. A stone tied to the end of string of length of 1 meter length is whirled in a horizontal circle with a constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of acceleration of the stone? You know that acceleration A is equal to r omega square and omega is equal to 2 pi by t, which can be written as 2 pi into nu, because nu is 1 by t. If If 22 revolutions take 44 seconds, then one revolution takes 44 by 22, which is equal to 2 seconds, which is the time, and nu is equal to 1 by t, so therefore nu is 1 by 2 hertz. A is equal to r omega square, r is 1 meter as given in the problem, and omega is 2 pi into 1 by 2 whole square, omega square, so therefore it is pi square meter per second square is the acceleration. If the acceleration is towards the center, it is centripetal acceleration, it is minus omega square r, and if it is away from the center, it is centrifugal acceleration, it is plus omega square r. So therefore both option A and option B are correct. Pi square meter per second and direction along the radius towards the center, and pi square meter per second and direction along the radius away from the center. Question 7. The vectors A and B are such that A plus B is equal to A minus B. The angle between the vectors is. I think this is the repeated question. A plus B is equal to A minus B. There are two methods to solve this question. We will solve another method in the upcoming question, which will be repeated. Squaring on both sides, A plus B whole square is equal to A minus B whole square, and A plus B whole square is equal to A square plus B square plus 2AB, and A minus B whole square is equal to A square plus B square minus 2AB. So if we solve this, A square will be cancelled by A square, B square will be cancelled by B square, and minus 2AB, if it comes to left hand side, it becomes plus 2AB. So therefore the total resultant is 4 A dot B is equal to 0, and A dot B is equal to AB cos theta. So therefore cos theta is 0, theta is cos inverse of 0, theta is 90 degree. Option B. Question 8. A car runs at a constant speed on a circular track of radius 100 meter, taking 62.8 seconds for every circular lap. The average velocity and average speed for each circular lap respectively is. Total distance travelled in one revolution is 2 pi r. Average speed is total distance by total time. So total distance is 2 pi r and time is 62.8 seconds. If we substitute the value of pi, we get 200.05, which is 10 meter per second. That is the average speed. But the total displacement in one revolution is 0. So therefore average velocity is 0. It is 0 is the average velocity and average speed is 10 meters per second. So option C. Question 9. A particle starting from the origin 0, 0 moves in a straight line in the xy plane. Its coordinates at a later time are root 3, 3. The path of the particle makes with the x axis an angle of. This is the path of the particle from 0, 0 to root 3, 3. So we want to find the angle made between the x-axis. The angle is given by tan theta is equal to b by a, where b is the second coordinate and a is the first coordinate. It is b by a is 3 by root 3, which is equal to root 3. So therefore theta is equal to tan inverse of root 3. Theta is 60 degree. Question B. Question 10. A and B are two vectors and theta is the angle between them. If a cross b is equal to root 3 a dot b, the value of theta is. Again, the cross product of any two vectors is equal to ab sine theta if a and b are the vectors, and the dot product of a and b is ab cos theta. So again we get sine theta by cos theta is equal to root 3, and tan theta is root 3. Theta is equal to 60 degree. Theta is equal to 60 degree. 11. A particle has initial velocity 3i plus 4j and has acceleration 0.4i plus 0.3j. Its speed after 10 seconds is. Here we use the first equation of motion, v is equal to u plus ad. U is 3i plus 4j and a is 0.4i plus 0.3j and t is 10 seconds. So we get v is equal to 7i plus 7j. The magnitude of v is root of 7 square plus 7 square. It is 7 root 2 units. Option B. 12. 6 vectors A through F have the magnitudes and directions indicated in the figure. Which of the following statements is true? B plus C is equal to F. B plus C should be downward, but F is in upper direction, so equation A is wrong. D plus C is equal to F. D plus C, then it should be in the second quadrant. It is again wrong. D plus C is equal to F. D plus E is equal to F. Option C is correct, and option D, B plus E is again wrong because it should be downwards. So we get D plus C is equal to F is the correct equation. So option C is correct. 13. A particle moves in xy plane according to the rule x is equal to a sin omega t and y is equal to a cos omega t. The particle follows an elliptical path. Option B, a circular path. Option C, a parabolic path. Option D, a straight line path inclined equally to x and y axis. So here we go. x is equal to a sin omega t and y is equal to a cos omega t. By rearranging, we get x by is equal to sin omega t and y by a is equal to cos omega t. Squaring on adding both the equations, x square by a square plus y square by a square, left hand side is squared and added, is equal to right hand square is squared and added, sin square omega t plus cos square omega t, which is equal to 1. Therefore x square plus y square is equal to a square, which is an equation of a circle, so it follows in circular path. Option B. 14. A particle moves in a circle of a radius 5 cm with a constant speed and a time period is 0.2 pi seconds. The acceleration of the particle is. So radius is given as 5 cm, which will be converted into meter. Time period is 0.2 pi seconds. Centripetal acceleration, as we know, is equal to omega square r. Omega is 2 pi by t, so 2 pi by t whole square into r. Centripetal acceleration is equal to 2 pi by 0.2 pi whole square into 5 into 10 power minus 2, which will be equal to 5 meter per second square. The tangential acceleration is 0 since the particle moves with constant speed. So therefore AT is equal to 0. Total acceleration is equal to root of AC square plus AD square, where AC is the centripetal acceleration and AT is tangential acceleration. So therefore it is root of AC whole square, which is equal to 5 meter per second, and it is towards the center because it is centripetal acceleration. 14th is option D. 15. A missile is fired for maximum range with an initial velocity of 20 meter per second. If g is equal to 10 meter per second square, the range of the missile is. So initial velocity is 20 meter per second and g is 10 meter per second square. For maximum range, angle of friction is 45 degree. So therefore r max is equal to u square sine 2 theta by 2g, where theta is 45 degree. So therefore 2 into 45 is 90 degree. We get u square sine 90 degree by g. Sin 90 degree is 1, so therefore r max is equal to u square by g. U is 20 and g is 10. 20 square by 10, which is equal to 40 meter. 15 is option A. 16. A boy is moving with velocity 30 meter per second towards east. After 10 seconds, its velocity becomes 40 meter per second towards north. The average acceleration of the body is. Velocity towards east, v1 is equal to 30 I. Since I is on the x-axis, so therefore I is taken the direction. Velocity towards north, v2 is equal to 40j, the direction, meter per second. Change in velocity is equal to delta v, v2 minus v1. Final velocity minus initial velocity. So therefore you get 40j minus 30i. Delta v, the magnitude of delta v is equal to root of 40 square plus 30 square, which is equal to root of 2500, which is equal to 50 meter per second. Average acceleration is change in velocity by time interval. So therefore average acceleration is delta v by delta t, and time is given as 10 seconds. So therefore it is 50 by 10, which is equal to 5 meter per second square. 16 is 5 meter per second square. Option D. 17. For angles of projection of a projectile at angle 45 degree minus theta and 45 degree plus theta, the range described by the projectile are in the ratio of. We know that range is equal to u square sine 2 theta by g. For angle of projection 45 degree minus theta, u square sine 2 into theta is 45 degree minus theta. So therefore if we multiply 2, we get u square sine 90 degree minus 2 theta by g. But we know that sine 90 degree minus x is equal to cos x. Here x is 2 theta, so therefore r1 is equal to u square sine 90 degree minus 2 theta by g. So therefore it is equal to u square cos 2 theta. Sine 90 minus x is cos x, so therefore cos 2 theta by g. Equation 1. For angle of projection 45 degree plus theta, r2 is equal to u square sine 2 into 45 degree plus theta by g. Again we get sine 90 degree plus x. Also sine 90 degree x is equal to plus x is equal to cos x. So therefore again we get r2 is equal to u square cos 2 theta by g. So if we take the ratio of the range when the angle is 45 degree minus theta and the ratio of range of when angle is 45 degree plus theta, we get r1 by r2 is equal to u square sine cos 2 theta by g divided by u square cos theta by g. It is 1. 1 is to 1. 17. Option B. 18. A particle of mass m is projected with velocity v, making angle 45 degree with the horizontal. When the particle lands on the level ground, the magnitude of the change in its momentum will be. 18. This is the path of the particle projected with some angle theta. Horizontal momentum does not change because horizontal velocity does not change in a path of a projectile. So therefore change in vertical momentum is mv, m into v sine theta minus, and the velocity is same but in opposite direction. So therefore minus mv sine theta. We get minus into minus is plus, so therefore you get 2 mv sin theta, and theta is 45 degree as given in the problem. 2 mv sin 45 degree, and sin 45 is 1 by root 2, so therefore 2 mv into 1 by root 2. So the answer is root 2 mv. Option A. 19. The speed of a projectile at its maximum height is half of its initial speed. The angle of projection is 19. So let v be the speed of the projectile at maximum height h. So therefore v is equal to u cos theta. It is the horizontal velocity. Given that v is equal to u by 2. The velocity of projectile at maximum height is equal to the half of the initial speed. So therefore, and also v is equal to u cos theta. If we put it here, then we get u by 2 is equal to u cos theta. So therefore cos theta is 1 by 2 and theta is 60 degree. It is option A. 20. The horizontal range and the maximum height of a projectile are equal. The range of projection of the projectile is. Question 20. R is equal to h as given in the problem. Range is equal to maximum height. R is equal to u square sin 2 theta by g, and h is equal to u square sin square theta by 2g. If we solve this, we get sin theta by cos theta is equal to 4, tan theta is equal to 4, theta is equal to tan inverse of 4. Option B. 21. A particle has initial velocity 2i plus 3j and acceleration 0.3i plus 0.2j. The magnitude of velocity after 10 seconds will be. 21. Again v is equal to u plus at. Substitute the values of u and a and t. We get v is equal to 5i plus 5j. The magnitude is equal to root of 5 square plus 5 square. 5 root 2 units. Option B. 22. The velocity of a projectile at the initial point A is 2i plus 3j. Its velocity at point B is. At point A, it is 2i plus 3j. At point B, the horizontal velocity does not change. So therefore, in the direction of x, which is I, it will be same, plus 2i. But in the vertical direction, it is in opposite direction from the initial one. So if it is plus 3j, it should be minus 3j. Option A. It should be like this. 2i will be same, but 3j and the initial velocity is positive, then here it will be negative because it is in opposite direction. Option A. 23 vectors A, B, C, A, B and C are such that A dot B is equal to 0 and A dot C is equal to 0. Then the vector parallel to A is. So 3 vectors are given, so we use vector triple product. So therefore A cross B cross C is equal to A dot C into B minus A dot B into C. Here it is given that A dot B is 0 and A dot C is 0. So A cross B cross C is equal to 0. Cross product of any two vectors, here B cross C is taken as a single vector. So therefore A dot B cross C sin theta is equal to 0. Theta is equal to 0. So therefore the vector parallel to A is B cross C. Option C. 24. A projectile is fired from the surface of the earth with a velocity of 5 meters per second and angle theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meters per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. The value of the acceleration due to gravity on the planet is. So a projectile is fired on earth and on another planet and their trajectory is equal, which means the range is equal. They have given the initial velocity on earth and initial velocity on that planet as 5 meters per second and 3 meters per second. We should find the acceleration due to gravity on that planet. So we know that RE is equal to range on earth is equal to u square sin 2 theta by GE. RP is equal to UP square sin 2 theta by GP. Since the trajectory is same, RE is equal to RP. We equate these two equations and angle of projection also are the same. So sin 2 theta is gone. 5 square, substitute the UE and UP. 5 square by 9.8 as given on earth. The acceleration due to gravity is 9.8 equal to 3 square by GP. Acceleration due to gravity on that planet. GP is equal to 9.8 into 9.25 on rearranging. GP is equal to 3.5 meter per second square. 25, it is option A. 26. Sorry, 24 is option A. 25. A particle is moving such that its position coordinates x, y are 2 meter, 3 meter at the time t is equal to 0, 6, 7 at time t is equal to 2 seconds, and 13, 14 at time t is equal to 5 seconds. Average velocity vector from t is equal to 0 to t is equal to 5 seconds is. At t is equal to 0, position vector r1 is equal to 2i plus 3j. At t is equal to 5, position vector r2 is equal to 13i plus 14j. Displacement from r1 to r2 from time 0 to 5 seconds. So delta r is equal to r2 minus r1, 13i plus 14j minus 2i plus 3j, which will be equal to 11i plus 11j. Average velocity is equal to delta r by delta t. 11i plus 11j by 5 minus 0, 11 by 5i plus j. 25, it is option D. 26, a ship is moving westwards with a speed of 10 km per hour, and a ship B, 100 km south of A, is moving northwards with a speed of 10 km per hour. The time after which the distance between them becomes shortest is. So there is a ship A which is moving westwards, and another ship 100 km south of A, ship B, is moving northwards with the same velocity of 10 km per hour. We should find the shortest distance between the ships during motion, which will be this. So velocity of ship AVA is equal to 10 km per hour, velocity of ship BVB is equal to 10 km per hour. AB is equal to 100 km, and BP is the shortest distance, will be the shortest distance during the motion of the ship. Relative velocity between A and B is VAB is equal to root of VA square plus VB square, and this is the relative velocity vector, the resultant vector of both the velocities of the ships, which will be equal to 10 root 2 km per hour. Here in this triangle, since the resultant velocity vector will be 45 degree from x-axis and y-axis, so therefore sine 45 is opposite by hypotenuse. Opposite is BP, the shortest distance, and hypotenuse is AB. So therefore PB by AB. AB is 100 and sine 45 is 1 by root 2. 1 by root 2 is equal to PB by 100. So therefore PB is equal to 50 root 2 km. So therefore time after which the distance is equal to PB is velocity is equal to distance by time. So therefore time is equal to distance by velocity. Distance is 50 root 2 and velocity is 10 root 2. The relative velocity, we get 5r is equal to 10. This is the actual situation when the ship B starts moving towards north and ship A starts moving towards west. 50 km after B travels the distance of 50 km, A also will have traveled the distance of 50 km towards west, and the shortest distance between them will be 50 root 2 km. So 26th is option D. 27, the position vector of a particle r as a function of time is given by r is equal to 4 sine 2 omega t I plus 4 cos 2 omega t j, where r is in meter, t is in seconds, and I and j denote unit vectors along x and y. Directions: which one of the following statements is wrong for the motion of the particle? Magnitude of the velocity of the particle is 8 meter per second. B, path of the particle is a circle of radius 4 meter. C, acceleration vector is along minus r. And D, magnitude of acceleration vector is v square by r, where v is the velocity of the particle. 27, r is equal to 4 sine 2 omega t I plus 4 cos 2 omega t j. Velocity is the differentiation of position vector r. So if we differentiate sine theta, differentiation of sine theta is cos theta. Here 2 pi is constant, so it comes out. So therefore 4 into 2 pi is 8 pi. Cos theta again 2 pi t I. And here differentiation of cos theta is minus sine theta, so therefore minus sign comes here, and 2 pi comes out, so therefore 4 into 2 pi 8 pi sine 2 pi t j. Its magnitude is root of a square plus b square, root of 8 pi cos 2 pi t whole square plus of minus 8 pi sine 2 pi t whole square. So it's, if you solve this, we get root of 64 pi square and 8 pi meter per second. Here they have given the velocity is 8 meter per second, but its velocity is 8 pi meter per second square. So therefore option A is wrong. Other options are correct, may be correct. 28, if the magnitude of sum of two vectors is equal to the magnitude of difference of the two vectors, the angle between these vectors is. This is the repeated question. So, and this is the second method to solve it. If A and B are two vectors, magnitude of their sum, A plus B, its magnitude is root of A square plus this magnitude of any addition of any two vectors is root of A square plus B square plus 2AB cos theta. Equation 1. Magnitude of the difference is root of A square plus B square minus 2AB cos theta. Since A plus B is equal to A minus B, we substitute this, and here since we had in the previous problem we had squared on both sides, here we just substitute it. and then again we get theta is equal to 90 degree. 28 is option D. 29, a particle moves so that its position vector is given by r is equal to cos omega t x plus sin omega t y, where omega is a constant. Which of the following is true? Velocity is perpendicular to r and acceleration is directed towards the origin. Velocity is perpendicular to r and acceleration is directed away from origin. C. Velocity and acceleration both are perpendicular to r. Velocity and acceleration, option D, velocity and acceleration both parallel to r. In this question, since you have to find the relation between velocity, acceleration and the direction, so they have given the position vector r is equal to cos omega t x plus sin omega t y. The differentiation of r, the position vector give velocity, so therefore differentiation of cos is minus sin, and omega is the constant, it will come out, so minus omega sin omega t x plus differentiation of sin is cos, omega will come out, since it is constant, so omega plus cos omega t y. A is equal to differentiation of v again, so differentiation of minus omega sin omega t is minus omega square cos omega t x. Since differentiation of sin is cos and omega is a constant, again it will come out and will be get multiplied, so minus omega square cos omega t x. Here the differentiation of cos is minus sin and omega will come out, so therefore minus cos omega square sin omega t y, which is equal to minus omega square cos omega t x plus sin omega t y. A is equal to minus omega square r, since this is r here, so therefore since the position vector is directed away from the origin always, so acceleration is minus omega, since it is minus, it will be directed towards inside, towards the origin. And also r dot v is equal to cos omega t x plus sin omega t y into minus sin omega t x plus omega cos omega t y is equal to 0. Since dot product is 0, the two vectors are perpendicular. So the correct option is option A. Velocity is perpendicular to r and the acceleration is directed towards the origin. Option A. 30. In the given figure, A is equal to 15 meter per second square represents the total acceleration of a particle moving in the clockwise direction in a circle of radius r is equal to 2.5 meter at a given instant of time. The speed of the particle is. So the acceleration is given, the direction. We can resolve the acceleration vector in two directions, the component with the theta towards origin and component away from theta. So component with theta is cos theta, so a cos theta is equal to a cos 30 degree. A cos 30 is root 3 by 2, a is 15, so therefore 15 into root 3 by 2 meter per second square. Since AC centripetal acceleration is v square by r, v is equal to root of AC r. V is equal to, and AC is known here, 15 into root 3 by 2, and r is equal to 2.5 meter. So if we solve this, we get 5.69, which is approximately equal to 5.7 meter per second. So it is option C. 31. The x and y coordinates of the particle at any time are x is equal to 5t minus 2t square and y is equal to 10t respectively, where x and y are in meters and t is in seconds. The acceleration of the particle at t is equal to 2 seconds is. 31. X is equal to 5t minus 2t square and y is equal to 10t. This is in the x direction and it is in the y direction. So if we differentiate x, we get velocity in x direction. So differentiation of 5t is 5 and 2t square is 4t. So therefore, and also differentiation of y is equal to 10. So therefore velocity in x direction is 5 minus 40 and velocity in y direction is 10. If we differentiate the velocity, we get the acceleration, so therefore dvx by dt, acceleration in x direction is equal to minus 4. If we differentiate this equation, we get minus 4, and differentiation of vy is 0, since differentiation of a constant is 0. So therefore acceleration in x direction is minus 4 and acceleration in y direction is 0. Acceleration vector is ax I plus ayj. Ay is 0, so the whole component is 0, and ax is minus 4, so therefore minus 4i. Acceleration of the particle at t is equal to 2 seconds is minus 4 meter per second square. So the option B. 32. The speed of a swimmer in still water is 20 meter per second. The speed of river water is 10 meter per second and is flowing due east. If he is standing on the south bank and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to north is given by. So the river is flowing towards east and he is standing at the south bank and intends to reach the north bank. If he starts swimming in this direction, in the west direction, then he will take the shortest distance to reach north bank. and this will be his path, where the angle with north and west is given by theta, and this 5, and this is the 90-degree angle. So here we know that sin theta is equal to opposite by hypotenuse. Here opposite is 10 and hypotenuse is 20, so 1 by 2. Sin theta is 1 by 2, theta is 30 degree, 30 degree towards the west, option B. 33. When an object is shot from the bottom of a long, smooth, inclined plane kept at an angle 60 degree with horizontal, it can travel a distance x1 along the plane. But when the inclination is decreased to 30 degree and the same object is shot with the same velocity, it can travel x2 distance. Then x1 is to x2 will be. So this is the situation. The object is shot at an angle of 60 degree at first, and then the angle is changed to 30 degree. So when the angle is the object is shot at 60 degree, we know v square is minus u square is equal to 2as. For theta is equal to 60 degree, v square minus u square is equal to minus 2 into g sin theta 1 into x1, because acceleration here, acceleration is acceleration due to gravity, which is split into 2. This acceleration is resolved into g sin theta and g cos theta. Component with theta is g cos theta, and component away from theta is g sin theta. So g sin theta is the only acceleration working against the motion, so we take it minus g sin theta and substitute this in the place of a. So therefore we get x1 is equal to u square by 2g sin theta 1, since final velocity is 0. For theta is equal to 30 degree, we again substitute a, and then we get x2 is equal to u2 by 2g sin theta 2. x1 by x2, we solve this, we get sin theta 2 by sin theta 1. Sin 30 degree by sin 60 degree, 1 by 2 divided by root 3 by 2, we get 1 by root 3. So therefore x1 is to x2 is 1 is to root 3. Option D. 34. Two particles A and B are moving in uniform circular motion in concentric circles of radii Ra and Rb with speeds v and vb respectively. The time period of rotation is the same. The ratio of angular speed of A to that of B will be. So time period, as we know, is t is equal to 2 pi by omega. Since time periods are equal, t is equal to dv. 2 pi by omega A is equal to 2 pi by omega B, or omega A is to omega B is 1 is to 1. So this is option A. 35. Find the torque about the origin when a force of 3 J Newton acts on a particle whose position vector is 2k meter. So force can be represented as 0I plus 3J plus 0k Newton, and the position vector is 0I plus 0J plus 2k meter. Torque is the cross product of position vector and force. Tau is equal to R cross F. Then we solve this by determinant methods. The vectors I, J and K are written. Then the components of I, J and K of R is written in the first row, and then the components of F are written in the second row. Then if first we take plus I, then we leave the column and row containing I. We take 0, 2 and 3, 0. Then we take minus J. Then we leave the column and row containing J. We take 0, 2 and 0, 0. Then again plus minus plus K. Then we leave the column and row belonging including K. So therefore 0, 0, 0, 3. Then we cross multiply this by putting minus sign in between. 0 into 0, 0. Minus 3 to the 6. Plus I into minus 6. Minus J into this will be 0, and plus K into 0. So therefore the torque will be minus 6I Newton meter. It is option A. Thank you.